Well, what a fascinating story. Thanks, David and Eric, for those insights. Well, before we get to our last speaker of the day, again, just thanks to our sponsors like Kubota and Meadows Canada. They're all part of our loyal sponsor family at Farming Smarter. Also, don't forget to get your registrations in for the upcoming conference and trade show. That's February 16th and 17th. Mark them on that brand new calendar. It's going to be happening in person in Lethbridge. You can keep up to date on all the details, plus the latest Farming Smarter research news by becoming a Farming Smarter subscriber. So be sure and get that done as well. Watch for the upcoming feedback email to give input on this event. And remember, you can always log back onto this platform and catch anything you may have missed over the next week. It will still be active for one more week. Well, now we round out our day of global crop information with Dr. Ken Flower from the University of Western Australia. Dr. Ken worked for the Western Australian No-Tillage Farmers Association doing research and extension before joining the university. He currently teaches and does research there on conservation cropping systems and precision agriculture. He'll be talking with us today about farming systems in the Wheatbelt of Western Australia and also discuss some of those major challenges like, of course, dry seasons, subsoil constraints, and herbicide resistance. As well, we'll learn about some of the more recent practices that Australian farmers have been using to maintain or improve crop yields and some on the current research work as well. So, Dr. Flower?
Hello, my name's Ken Flower and I work with the University of Western Australia. Today I'm going to give you an update on cropping system developments in Western Australia. Firstly, I'll give you an overview of farming systems. And from that, you'll see that no-tillage dominates but has reached a plateau. Now, our main constraint is soil water, and we have declining rainfall. Another major constraint is that our soils are relatively impoverished and we have various subsoil constraints. And then thirdly, another major challenge is herbicide resistance. Once I've gone through these constraints, I'll then move on to recent changes and practices that farmers are implementing to try and improve yield given these constraints. And finally, I'll go through some new research that's coming along in the pipeline. So here's a map of Australia. And the areas shown in green there are those that experience a Mediterranean rainfall environment. So we have hot, dry summers over the December period because we're in the southern hemisphere, and then cool, wet winters. And the graphs that are shown there, just to the left of the screen, you can see that in the middle of the year, around June, July, is when we experience most of our rainfall. So it's cool, wet winters around June, July, with hot, dry summers and no cropping over summer. Western Australia is a relatively large area, and particularly the wheat belt, which is shown there in green. And you can see the distance here I've just given you between two of the towns at different sides of the wheat belt is about 600 kilometers. So a fairly large area. So we have the hot, dry summers with average temperatures, maximums around 35 degrees Celsius, and temperatures can regularly get over 40 degrees Celsius. We then have our cool, wet winters when we grow our crops, and average maximum temperatures around 18 degrees Celsius, but we can get quite frequent frosts around flowering time or anthesis, and that can cause problems with our cereal crops. Rainfall varies tremendously over the Western Australian wheat belt, but I've put here an average of about 350 millimeters, but that's going to range from about 250 further inland to around 400 millimeters closer to the coast, and most of that rainfall falls in winter. So looking at our cropping farms, most of our cropping farms are large single-family farms, but the number of corporate farms are increasing. Most farmers will crop between 2,500 to about 4,000 hectares, but some of the larger farms can get over 10,000 hectares, so big farms. Many of the farms are mixed crop livestock, which have merino sheep, but then an increasing number of farms that only crop. It's a highly mechanized system, and most of the tractors and machinery have GPS guidance, and there's little hired labor. Now, no-tillage is the main cropping system, and more than 95% of farms are using no-tillage. There's also a very strong dependence on herbicides, and hence, I'll talk a bit later on, we have the issue of herbicide resistance. Now, wheat is the main crop, followed by barley. Then next largest is canola, oats, and lupins. So cereals really dominate our rotations, and canola has been increasing because of the good weed control options. And also you'll see that there are very few legumes that are grown in our system. So we need more legumes. That's another challenge. It's a relatively low input, low output system. So low, relatively small amounts of fertilizer, and our yields on average are around 2 tons per hectare for wheat, for example. But this does vary a lot. It's a low rainfall environment and poor soils. The top 10 centimeters of soil have organic carbons around 1% or less than 1%. So quite impoverished soils. In terms of our seeders, most of our farmers use a seeder which have tines and knife points. And you can see the press wheel there. So tines and knife point seeders dominate. There are some farmers who use disc seeders, but they are in the minority. Our main constraint, as I mentioned earlier, is soil water. And stubble retention is the key, both from the point of view of erosion. We have the risk of wind erosion, particularly at the end of summer when there's very little stubble. We have strong winds, and we can lose a lot of topsoil. So keeping the stubble there is absolutely essential, also for improved infiltration and soil water conservation. So stubble retention is a key part of our system. Farmers also need to manage the size of the canopy. For example, not apply too much nitrogen fertilizer early on and grow a big canopy, because sometimes we have insufficient soil water to fill the grain at the end of the season. Our row spacings are around 25 to 30 centimeters between crop rows. The 30 centimeters are more applied in the drier areas. Our nitrogen is applied like in most areas around the world according to the season, and amounts would vary from about 40 to 80 kilograms of nitrogen per hectare. Herbicide resistance is another major challenge. We have a heavy reliance on herbicides, and Harries et al. In 2020 published a paper that showed that on average 5.4 different active ingredients are applied per paddock per year. So that's quite a bit of herbicide, and glyphosate dominates. Now going through recent developments. Let's look at some of these farming decisions that farmers are adapting and fine-tuning to try and improve their yields. Firstly, seeding decisions. Now we have a hot, dry summer, often very little subsoil moisture, and then we do get some light opening rains. And what we find in some conditions, some seasons, is that you get more soil water directly underneath the stubble row compared to the inter-row, as you can see in this photograph here. So farmers at seeding time need to decide where exactly to place their seed in relation to the previous row of stubble. So for example, if we've had good early rains prior to seeding and plenty of subsoil moisture, most farmers will decide to place the next crop directly between the two rows of stubble, particularly if they're growing wheat after wheat, because one gets less disease and a better crop establishment, and stubble handling is easier. However, if we get the condition like shown in this photograph, where it's a dry early start, you might have got a little bit of rain and then it's dry. What farmers might do is nudge their guidance system over to actually seed adjacent to the previous stubble row, so that they can put their seed into moisture and get that crop up early. So that's some of the decisions that farmers are taking to try and get the crop up earlier, because early seeding means generally higher yields in our environment. Here's an example where you can see the effect of seed placement relative to the previous row stubble. So on the left-hand side, where we have poor emergence, that canola crop was seeded directly between the two rows of stubble, so inter-row seeding. On the right-hand side, we have where the seed has been placed either on the row, previous stubble row, or adjacent to the row, and you can see much better germination. And so farmers can get that crop up early by improving that by putting the seed where the moisture is in the field. Another seeding decision is how deep to place the seed, particularly if we get fairly early rain, reasonable rain, and then a long dry spell approaching seeding, because we might have moisture deeper down and the surface might be dry. The decision then is how deep do you put your seed. So in this example, we had a trial where we've got the seed at 3 to 4 centimeters and nothing came up until we got the main rains in June, which is quite late emergence. On the right-hand side, where we put the seed deeper, we got very good emergence and early establishment. Now we know that putting the seed too deep often results in poorer emergence and sometimes lower yields. But if we can get the crop up early, then the results have shown that if we get early establishment, then we tend to improve yields. So there's a lot of research going on at the moment for breeding varieties with longer coleoptiles to try and give farmers the options as to whether to seed. They can seed deep and chase moisture, or they would decide to put the seed shallow. Another relatively large change you'd have probably picked up by now is that generally we'll try and seed our crop as early as possible, because the earlier we can seed, particularly if you've got a large area to get through, then the earlier you can get part of your crop in before the rains start even, then the higher generally the whole farm yield. So even before the rain starts, some farmers will start, it's called dry seeding. So the soil might be bone dry, farmers will still go in and seed. They used to start around mid-May, and now some farmers start the end of April or even at the beginning of April. There's a few farmers who start at the end of March even. So you can see that there's a push for earlier seeding. Now that earlier seeding, generally they will seed crops like canola and lupins first and then go into their cereals. And that early seeding date has got to be matched with a variety which has the right maturity, with its short season or longer season. But generally that's been a big change. Farmers are seeding earlier and earlier, even under dry conditions. They will tend to set up those paddocks and only dry seed paddocks that have relatively low weed pressure, because obviously the herbicides are not going to work so well under those dry conditions. And that's another area of research, is which herbicides and which conditions are optimal for weed control with this very dry seeding. Another change that's come in recently is the use of strategic tillage to increase root exploration. So I should emphasize that we are still in a no-tillage system. Farmers will use occasional strategic tillage once every 5, even 10 years to improve crop yields and largely through increased root exploration. And then they will go back to their no-tillage system. What are the reasons for this? Well, we have subsoil acidity, and therefore the only way to get that subsoil acidity ameliorated is to incorporate lime. We also have aluminium toxicity, often associated with that those very acid soils. So we need to incorporate lime. We also have what are called hydrophobic soils. So where we have sandy surface soils, particularly with the hot conditions, the waxes melting around the particles of sand, and we get hydrophobic soils as shown in that photo on the lower right-hand side there. Now, the only way to alleviate hydrophobic soils or non-wetting soils is to incorporate clay. So if there's some clay slightly deeper down in the profile, then using this implement here, which is a spader, like a rotary hoe, but a bit larger, we can incorporate lime or to mix clay into the surface to reduce this problem of non-wetting, which causes very poor establishment. So farmer might have both non-wetting soils and lime, and therefore it pays the farmer to do the spading and to ameliorate both of those constraints. Another constraint is compaction. Some of our sands will naturally compact, particularly where they have a range in particle size. So sand might be the predominant particle size, but they may also have clay, some clay and silt in the soil and very low organic matter, and those soils can tend to compact. So every number of years, there's some research going on to find out the optimum number of years, but only on some soil types that naturally compact, farmers will use a ripper, as shown here. So it's deep ripping, can go down to 600 millimeters or 60 centimeters deep. After that, the farmers would tend to go onto a controlled traffic system because they've ripped up the soil, loosened that soil, and then one doesn't want to be driving all over it. So gripping and then into a controlled traffic system. So this is to alleviate compaction. And the research and farmer experience has shown that yields can improve significantly after ripping some of these soils. Another reason for doing strategic tillage is to bury herbicide-resistant weeds. And you can see here, this is done with the moldboard plow, which inverts the soil. Now, in a no-tillage system, you probably know that most of the weed seeds are in the top few millimeters of the soil because it's in a no-till system and the seeds are sitting there. That's where the seed bank is. So the moldboard plow, we can bury those seeds, invert the soil and bury the seeds down at about 25 to 30 centimeters where the seed doesn't germinate. And you can see this in this image. It's the same field. You can see the trees in the background. The farmer applied the normal herbicide practices on half of the field and he moldboarded the other half of the field. And you can see where he's applied the herbicide, we've got resistant ryegrass growing all over the place there. And you can see that in the top image. In the lower image, the farmer has sort of reset that herbicide resistance clock by moldboard plowing. The farmer wouldn't then come in and moldboard for many years after that, a number of years, because obviously that would bring the weed seeds back up again. So this really helps and can be combined with other ameliorants like lime as well. So one can kill two birds with one stone, so to speak. Now, I've been talking about herbicide resistance. It's a good segue into another method that farmers have been taking up to deal with herbicide resistance. And this is another non-chemical method of controlling this, and that's called harvest weed seed management. Now, the concept behind this is that most weed seeds, in our system anyway, remain on the plants during harvest. So the weed seeds, the pods do not shatter, the weed pods do not shatter. So they remain on the plants at harvest. We then come through with a harvester and the weed seeds are going into the harvester. They're mostly separated into the chaff fraction, and then we generally spread them back out over the field. So we're reseeding our seeds, weed seeds, back over the field. And that's the concept between harvest weed seed management. Why spread those weed seeds back over the field? So harvest weed seed management is a way of killing those weed seeds that are in the chaff fraction and get taken into the harvester. So I'll outline 3 different methods of harvest weed seed control, going from the most expensive, most sophisticated, probably the best option, through to the cheaper option. Firstly, it's called a seed destructor, and Ray Harrington was a local farmer who brought the concept to the Australian Herbicide Resistance Initiative, ARI, and they worked on it together with Ray Harrington and developed this concept. So with the Harrington seed destructor, the destructor is actually fitted into the back of the harvester. So the chaff fraction with the weed seeds are milled within the harvester. So those weed seeds are then killed through milling, and then all the residue, that's the chaff and the stubble, is then spread behind the harvester. So all the organic material is going back out over the field, and the weed seeds have been killed. So that's the seed destructor. So it's a non-chemical method to deal with any weeds, but particularly herbicide-resistant weed. So the next form of harvest weed seed management is the chaff deck, where in the harvester, the chaff and the weed seeds are placed onto the 2 wheel tracks. And you can see here we have the chaff deck dropping the chaff and the weed seeds onto that wheel track. The weed seeds are then concentrated in the wheel track, which is a pretty sort of harsh environment. And when the first rains come, the chaff starts to compost a bit, and you get some of the weed seeds are killed. Alternatively, the farmer knows where those weed seeds are and could apply a broad spectrum herbicide with a shielded sprayer to control those weeds. The final method I'll talk about is windrow burning. And with windrow burning, the chaff and the straw is laid in a narrow windrow at harvest, and then just prior to seeding, that windrow is burnt. And the high temperatures, because we have sufficient chaff and stubble there, the high temperatures kill most of the weed seeds. And this is a very effective method of harvest weed seed control. It does require a little bit more labor to go and burn. And also there is the risk, obviously, particularly with leafy crops like barley, that the fire can get away and burn the field. But farmers have become good at predicting the optimum conditions and have become quite skilled in just burning those narrow windrows. So this is an effective and relatively cheap method of harvest weed seed control. Now, finally, I'll just go on to some of the current research. Still on this theme of harvest weed seed control, we have another issue in that some weeds shed their seeds before harvest, and therefore they are taken into the harvester, but without the weed seeds. So the weed seeds are already in the seed bank. So we can't really control those using our non-chemical harvest weed seed control. And this is the subject of a PhD research project run by Nu Shin, who is looking at mapping weeds above the crop canopy, because it was noticed that a lot of these weeds, particularly here, for example, wild oats, that these plants grow above the crop canopy and you can pick them out easily. So the idea here is that if we could map where these weeds that stick above the crops, like wild oats, which shed their seeds, then we could map where those seeds would be for the next year in the approximate area. So we'd know broadly what area those wild oats are in. And then we could apply some targeted management in the next year. For example, when we come into seed next year, we could apply variable rate seeding and increase the seed rate, double or triple the seed rate in the areas where we know that those wild oats are seeded, and therefore increase crop competition. Alternatively, or another practice could be that if we know that those are wild oats, then we can apply a wild oat herbicide, pre-emergent herbicide, just in the area where those weeds are. So we can target those areas. So Nu Shin's research project was to map weeds poking out above the crop canopy. And two of the weeds, for example, here you can see on the left-hand side is wild oat, and on the right-hand side is brome grass. So what the research project was on was using LiDAR, or light detection and ranging, on a harvester, or it could be fitted on a sprayer. So as the harvester or even the sprayer earlier on is moving through the crop, that LiDAR sends out laser beams and is picking up the surface of the crop, so we can pick up where the crop canopy is and detects any weeds sticking out above the crop. And the result is a map like this, which could be turned into a prescription map, where we have the blue being the surface of the wheat and the green there where we have hot spots where weeds have been detected sticking up above the crop. And as I say, then next year, for example, we could apply variable rate seed when we're seeding our crop to increase the seed rate in the areas we know that these weeds exist. So that's one of the research projects. Another research project being carried out by the Department of Primary Industries and Regional Development, which is the Department of Agriculture, by Dustin Severtson. And we also have some master students working on this. It's to do with scouting insects. So mapping insect damage using drones. So Dustin has been working on mapping using live NDVI and also various cameras to pick up aphid damage or other insects. And the idea here with a live NDVI, here's an example where Dustin was flying over a farmer's crop, and you can see the high biomass areas are shown in red in this image, which is usually, it's opposite of what you'd usually think of, but it's been colored red in this image. And where there's low biomass or gaps, plants missing, that's green and blue. And so by flying over there with a live NDVI, the farmer or the agronomist can then pick up where there are potential issues in these very large fields, and then it would still need some ground truthing. So driving into the field, stopping in that area, and they confirmed that in this instance it was the cockchafer or scarab beetle larvae that was attacking barley. So using drones to map insect damage and to help with scouting. Finally, we have another research project, PhD run by Hera, who's looking at mapping of soil water using electromagnetic induction. So with the EMI, we would be looking at using an EMI instrument of some sort, like a dual M, pulled over a paddock in swaths to map the electrical conductivity. Now, once we've mapped the electrical conductivity down to, for example, 90 centimeters or deeper, depending on the instrument settings, once we've done that, then the student has then gone into the field and taken soil samples to depth, taken those soils back to the laboratory, and has set up so that the student could measure the loss of soil water and measure the resistivity of that soil at the same time. So measuring loss of soil water against resistivity, and developed calibration curves of the electrical resistivity against the soil moisture. Now we know that the conductivity is the inverse of the resistivity, and therefore from that we can get the soil moisture content from our EM survey. Now different soils will obviously have different properties, different amounts of organic carbon, and different electrical conductivity. So we would have to develop a library of calibration curves for different soil types that farmers could pick up and then measure their soil water from the EM survey. And here you can see an example of the work to measure the electromagnetic induction to map soil water. And this was taken from one of our trials where we have, Hera has measured the soil volumetric soil water content at different depths in the soil. And you can see where we have different plots, and where I've highlighted there in red is where we had a fallow plot. So you can see that the soil volumetric soil water content has been picked up. So the idea here would be, in the future, would be able to use the EM to map every time a farmer, for example, drove over a field, the farmer could map soil water down to depth and then have a good idea about what the yield potential for that paddock was. Looking at the forecasting for weather, can decide on what inputs then to apply to that. So I hope that's given you some overview of our cropping system developments in Western Australia, and look forward to answering any questions. Thank you.
Now, we did have one question come in early, Dr. Flower, about, your weed seed management and how to get rid of that. And the question was, isn't burying the seed just delaying the inevitable by, when you bury the seed out behind the combine? So is that just delaying the inevitable? Talk to us about that.
So, when you're burying the seeds, I'm not sure if you're meaning burying it by using tillage or just dropping the seed directly behind the harvester on the wheel track. So if you're burying it by tillage, then with a moldboard plow, it's actually going down about 25 to 30 centimeters. So we're burying them at that depth, and that will actually, it does extend the life of the seeds, but because it's a no-till system, you wouldn't be using tillage. You'd only be using tillage once every 5 or 10 years. So by that time, the weed seeds would have generally died. So it's like sort of resetting your weed, resetting that herbicide resistance clock, as it were, back to zero. That's the intention there.
George, did that answer your question? I think that was one that you had asked.
Yes, that's exactly what I had asked. Thank you.
Okay. Trevor, I see your smiling face. Does that mean you have a question for Dr. Flower?
Yeah, for sure. Thanks. Hi, Ken. Thanks for your presentation. It's been super interesting all day to hear the differences around the world in weather today and just farming practices in general. And yeah, your presentation was super interesting. And I was just curious about your weather down there. Do you guys get lots of wind? Are you concerned about wind erosion of the soil? And like, how susceptible are the soils to wind erosion with such high sandy soils?
Yeah, they're very. Yeah, carry on.
Oh, I was just going to say, yeah, like here, especially this fall, in the spring as well, like we've had a huge soil erosion problem here in southern Alberta, and like we're getting winds 60 to 100 kilometers per hour. It's just fairly normal. Yeah.
Actually, that's actually what started the whole no-till revolution, because I think in the 90s, tillage has been common practice for quite some time, and then on the south coast we do get strong winds, particularly in autumn, and if with the bare soil, very sandy soil, we get a huge amount of erosion. So farmers were finding fence posts or fence lines completely buried. So pretty bad. And so actually it was the farmers who started the no-till revolution down there. And it's interesting, quite a few scientists were skeptical, and it was driven really by growers who, decided, they couldn't carry on like that. So that's actually what started the no-till. And occasionally when we do get fires coming through, which could be, started by a harvester or something by mistake, or there's a few farmers who still do burn their stubbles. that's very prone to erosion. And, we had one blowing recently at sort of end of last year, just at the end of summer last year, and you lose a few, 5 to 10 centimeters of topsoil, and that's in our system, that's where most of the organic matter is sitting. So it can happen pretty rapidly, and that's why keeping the stubble on the soil surface is absolutely crucial. And that's a question with regards, the tillage. Some people are saying, are we going back to tillage? Well, that's why I sort of emphasize it's very much strategic tillage. It's, where farmers' yields are dropping because the weeds maybe have got on top of them, or due to herbicide resistance, or the soil pHs. We can get soil pHs as low as 3.8, 3.9 at depth. So, in the subsoil, so we need to apply lime. And really the only way to get it down there is to till. So what farmers will do is till and then immediately sow something like barley, at a very high density to try and get cover over there. And even if they don't harvest that, it's just to get that some cover to stop the wind blowing. So it is a big issue here. Yeah.
All right. Yeah, good question. With that dry challenge as well, it was interesting to hear your observation that they're moving earlier on seeding so they can try and capture some of that moisture and then going deeper. But I guess when you're going earlier, have you found that magic number yet, or does it vary quite a bit on where how deep you can go before you impact yields on the other end? Because that's what you're searching for, isn't it? That magic intersection where you can go deep to get the moisture and not cut too much in the way of yields.
Yeah, no, that's a good question. It's actually, it's a little bit of an art more than a science, to be honest, because every season is different. So, if you don't get any early opening rains, farmers will just seed into dry soil. And the idea is that by the time the highest chance of the rain coming, which is sort of towards the end of May, there's a good chance that the opening rains would have happened by then. You at least have got half of your crop in. So, maybe even 2/3 of your crop seeded completely dry. But then that means that, then you should still, as you carry on seeding, you'll finish in good time, because once you get into June, your yields, research has shown, I can't remember the figure exactly, but it's almost, it's like 1%, a few percent, 5% per day or something like that, or 1% per day maybe, decrease, every day that you're delaying once you get into June. So, that's why farmers want to get most of their crop in, even if it's completely dry. And because on average, farmers will be seeding about, 3,000 to 5,000 hectares of crop. So then, you have to start early. And traditionally, they used to start seeding with the rains. So that could have been, early May or late May, or, end of April, something like that. But they would just only start after the rains. And when we had to use tillage, then they would have the first tillage going in then. And so everything was really delayed. Yeah. So it's been a big change.
And I guess you don't have to worry about frost on the early end of the seeding, which sometimes farmers in this area have to deal with if they get in too early as well, too cold a soil.
That's right. So the frost, we have no issues with frost early on. The big frost problem comes at flowering time. So, farmers can get 80, 90% reduction in yield from having frost at flowering. So we can get heavy frosts in the central wheat belt. I think they've estimated, about $230 million worth of crop lost in over a number of years. So it's quite significant. Actually, there's a huge research program on how to mitigate frost damage in wheat.
Interesting. I see Ken here. And so Ken, I know that means that you have a question.
Hi, Ken. It's Ken here. I could ask you about 7 questions, but I'm going to stick to 1. Thanks for the presentation. I'm interested in the comments that you made on strategic tillage for root exploration of moisture. We've been going through some pretty significant droughts lately. I found that we found sometimes that like a deep banding approach sometimes does actually allow for that, but it's kind of a underdeveloped process here. I'm wondering if you could share a little more about that.
Do you mean the sort of deep banding of the seed?
No, for us, we did have a trial where we did a 1 in 3 year sort of a 6-inch deep tillage pass.
Oh, okay.
And we did find that in those dry years that it did seem to help the crops, but it's really not a common practice here. So I saw that you had done some work in that. So just wondering if you could elaborate a little bit.
Yeah. So most of our, there's actually various reasons why farmers would use that tillage. And what I think the one you may be sort of referring to is more that compaction. And so farmers would be ripping down to probably the shallowest they'd be going is about 40 centimeters, and some are even trying to go down to 60 centimeters. So it's quite deep ripping there. And they've found, in the year following that ripping, they've found, huge increases in yield, and that yield increase continues for a few years. And I think it's when they're doing some sort of soil profiles and cutting through that, it's clear that the roots haven't been able to penetrate, deeper down into the soil, because our soils will compact naturally, even without, traffic on them. So, and the question is, how often should farmers be doing that? So, that's what the ongoing research is, but it's only on some soils. Other soils, sort of with more clay in them, a little bit better structure. The ripping, farmers have tried it on there and had no response at all. So it's really only soils that, are suffering from that compaction.
All right. Just a reminder again, you can ask your questions in the chat box area, or again, put your hand up. Oh, Ken, you disappeared. I thought I would give you another question since you said you had about 7 of them.
Well, I can do a quick follow-up. We kind of, myself, I was almost raised in the zero tillage movement. So tillage is almost sacrilegious here.
Taboo,
And most
yes.
of us, most of us haven't even seen a plow in action. And George was sort of saying that the inevitable. What are the concerns regarding damaging soil structure? And, Trevor sort of alluded to the risk of erosion and doing those events as well, because I think we've some folks are dabbling in this idea of strategic tillage, but it's almost like we'll think less of you for trying that.
Yeah, no, look, Ken, I can completely understand. I worked for a number of years for the No-Till, WA No-Till Farmers Association, and I've written many articles about, how damaging and, even particularly information that came from South America indicated in their conditions that if you use, even one tillage, you're going back 20 years in your no-till journey. And therefore, it was absolutely, you should not use any tillage at all. And I was certainly one who've had to eat my words, to be honest, because, for some farmers, they really don't need tillage at all. Their systems are functioning well. They're getting yields comparable, if not, some of the top yields in the region. But with other growers, because they have specific issues like subsoil acidity, or their herbicide resistance problems are so large, or also, increases in non-wetting soils or hydrophobic soils in our very, very hot summers, over Mediterranean type summers. particularly it seems after growing some of the legumes, the wax is melting over the sand particles and we get very non-wetting soil. So you can pour a bottle of water on it and just sit on the soil surface. Eventually it will find a pathway to go in. But so you can imagine the early opening rains, you're getting very, very poor germination in those conditions. And the only way to alleviate that is to mix in clay. And if you've got a little bit of clay, heavier soil further down, then, bringing that up with spading or something like that, mixing clay into the surface can go, you can move from a very poorly established crops, low yields to, increasing yield by 1 or 2 tons a hectare, which is massive for a grower. So, farmers will use that strategic tillage where yields and issues have become pretty large. And I think there's a saying, in farming is like, never say no to something, and never stick on a path absolutely without considering other options. So, and that's why I emphasize as well is that, once farmers have done the tillage, then they're going back straight as quickly as possible into the no-till system. What our research has found that we've got low organic matter soils. I would say in soils with a good structure, then you can probably use sort of natural systems, growing lots of deep-rooted crops in there to maintain and improve your soil structure, and you wouldn't necessarily want to use any tillage. But our soils really are pretty unstructured. I'd call them sort of massive type of soils. Very few of them, that you can find, large aggregates in them at all. So pretty infertile soils, and the tillage is shown to, in some circumstances, to improve the situation. And I think the research is showing that a one-off tillage is actually not. There's enough published papers now to show that it really it doesn't reduce your organic matter. There's been no noticeable drop in organic matter. If you till multiple times, then you're going to drive your organic matter down. But a one-off tillage that results in higher biomass production the next year and a few years afterwards actually is then increasing your carbon inputs back into that system. So, we're pretty confident that using it very occasionally and then going back to a no-till system it's really to alleviate a specific issue.
And really that approach kind of lines up with some of the messages we've heard earlier today about, reading the situation and adapting to it. So if your situation is one where it would help, I guess, then that's something to consider, and not being stuck to any one thing.
That's right. And we have had the occasional farmer who's tilled on very light sands, and then, the next week has had a huge wind come through there and blown a lot of topsoil. And so, that hasn't worked. So you still get those, and those are problematic. There's no doubt. But on the whole, growers are very conscious now, particularly of getting cover on their land, and so they will immediately, sow high density cereal straight into there, and if not broadcast it and do a light rolling because the soil will be probably loose and fluffy. It's hard to even seed into that. So just to get some sort of cover in there. And even if they forego 1 year's actual crop and just get some cover on there, that's worth doing.
Great. Now, if people want to read any more about some of the research work that you're doing, is there a website or a way to kind of catch up on some of the projects you're keeping eyes on? That's
a good question. Yeah, well, some of the information is with the No-Till Farmers Association, and then there's also at UWA we have an Institute of Agriculture. So, for example, the work that we're doing on insect detection, that is at the University of Western Australia Institute of Agriculture website. So,
Okay.
Growers can, and I'm happy to, growers, you're welcome to email me if you've got any questions. I'm happy to answer those as well directly.
Great. Well, thank you for sharing that information. And don't forget, the networking session of this Feed Loop platform does give you an opportunity to kind of get that networking information, the contact information shared. So you can do that through the platform, because the platform will be active for another week. And so people can, network back and forth and exchange information. So thank you so much, Dr. Flower. We'll let you go have your breakfast. Enjoy your warm day while we shiver the night away.
It's a pleasure talking to you all. Thanks.
That's Dr. Ken Flower from the University of Western Australia. A couple of reminders, of course, as we wrap up today. A big thanks to the Farming Smarter team members who put a lot of hard work into the program. Of course, especially Sean, the great voice you've been hearing above and beyond, and helped out with the Australian interview about the wheat yields, or the New Zealand interview about the wheat yields. And also, of course, Jamie and Morton helped with all the videos. Thanks to all of our Farming Smarter team for making this day possible. Remember to consider becoming a Farming Smarter partner so that you can have access right away to any of the presentations that the Farming Smarter does throughout the year, as well as their research and all sorts of other benefits of the subscription. Don't forget to get your registrations in for that February annual conference, February 16th, 17th. That's the new dates. Be sure and get signed up for that.